The cardiac cycle is a cyclical nature. You can see it's one continuous cycle. So if we have to pick a starting point, we'll start right here where we have an isovolumetric relaxation. What that means is the entire ECG, the P, QRS, and T waves have all completed. What we have now are the ventricles are starting to relax from their contraction. Because they're just starting to relax, we have not opened up the right and left atrioventricular valves yet. The pulmonary and aortic valves are closing because of the blood trying to push back into the relaxing ventricles. So once those ventricles fully relax, the right and left atrioventricular valves can open up. Blood can flow passively into the ventricles from the atrium. Now, as they're filling, eventually we get to atrial contraction. Now, atrial contraction is atrial systole. This is denoted by the P wave in the ECG, or electrocardiogram. What's happening here? The atria contract, forcibly pushing blood into the ventricles. Once that concludes, we enter into this isovolumetric contraction. This is where we find the QRS complex. So what's happening here? The ventricles are starting to generate pressure. They're contracting. That means they've closed both the right and left atrioventricular valves, or the tricuspid and bicuspid valves. Those valves are closed. In addition, the pulmonary and aortic valves are also closed. The pulmonary and aortic will remain closed until the ventricles have created enough pressure to push the blood that was in the pulmonary trunk and the blood from the aorta out of the way. So now we have entered the ventricular ejection phase. The ventricles have generated enough pressure to open the two semilunar valves. They'll keep pushing blood out or ejecting blood until the contraction ends. Ventricular systole will end when you reach the T wave, which is ventricular diastole. At this point, the ventricles can start to relax. They start to open back up, and we're in that isovolumetric relaxation phase that we started in. Now, I dive a little bit more into what's going on in this whole cycle. To go a little deeper into what's happening in the cardiac physiology, we're going to look a little more at our ECG, our electrocardiogram, the first top line here. You'll notice that we have two complete cycles, one cycle first, and here's our second cycle. The P wave, the first part of the cycle, is going to be atrial systole. This is when the atria are contracting. Remember, both the right and left atria are going to contract simultaneously. We then move into our QRS complex here. This is ventricular systole, when the ventricles are going to start contracting. If you notice, we have this little area here from the solid line to this dotted line. That is the isovolumetric contraction. Remember, that is when all four valves are closed. The ventricles are starting to generate pressure. You'll notice that at that isovolumetric contraction, we have our first heart sound. The heart sounds for the first and second are coming from the closing of valves. This first heart sound is when both the right and left atrioventricular valves close, or the tricuspid and bicuspid valves. The ventricle then continues generating pressure until it reaches the point where it can eject the blood. Once that concludes, we enter the T wave, which is going to be our isovolumetric relaxation. you'll notice at the end of that, we have this isovolumetric relaxation. We have our second heart sound. The second heart sound is going to be when the semilunar valves snap shut. This is the pulmonary and aortic semilunar valves. Once that concludes, we then have the blood flowing rapidly back into the atria and the ventricles. Because at this point, back here, when the ventricle is still contracting until it starts relaxing, no blood is flowing from the atria to the ventricles. Once you have full relaxation here, now the blood can rapidly fill back into the ventricle. That puts us in diastasis. We now are relaxing until the next cardiac cycle starts again. You're going to notice there's also a third heart sound shown on this graph. Now the third heart sound is something that can occasionally show in children and in athletes, but mainly going to focus on the first and second for the closure of the valves. If we add this chart now, we've added all these lines which are showing pressure, millimeters of mercury. This gray line down here that stays lower is going to be your atrial pressure. The blue line with this large jump is ventricular pressure. This top line that is going between 80 and 120 millimeters of mercury, that's your aortic pressure. So to correlate, you'll notice that both the atria and the ventricle have a small increase in pressure right here. If you notice, that's just after the P wave, just after the atrial contraction. Atrial and ventricular pressure will decrease just as the graph is labeling mitral valve closes, but don't forget that's also the closure of the tricuspid valve. We're just focusing on the left-hand side of the heart for this purpose. Once that valve closes, you'll notice how this blue line is increasing quite dramatically. That's the pressure increase inside the ventricle. It's trying to reach the pressure inside the aorta. Once the two pressures are equal, the blood can start being pushed out of the ventricle. This means it's now ventricular ejection. It's having enough pressure to push the blood that was in the aorta out of the way. It keeps pushing the blood out until you reach your full systolic blood pressure. This graph is showing 120, but it's whatever the systolic is of the individual. Pressure starts to decrease. Notice we're now corresponding with a T wave. The ventricle is starting to relax. Right at this point, then at relaxing, we are noticing that we start isovolumetric relaxation. The aortic valve closes. Then the ventricle pressure keeps decreasing, but that aortic valve closure helped to maintain the pressure inside the aorta itself. The pressure decreases all the way until you're able to open up the mitral valve, and for that matter, the tricuspid valve. That means now we have a rapid influx of blood flowing into the ventricle, but pressure remains practically zero. Reason being, the ventricle is relaxing. It's not contracting. Now, if we add to that and take the rest of this chart, we're adding in volume. Here, we're looking at the ventricular volume in milliliters of blood. When we start, you can see the increase right here. This increase, if you notice again, is an increase in blood going into the ventricle because now we're at the P wave. That means we have the atrial systole. It's pushing the blood actively into the ventricle. Right here now, we're kind of holding steady. This is now our isovolumetric contraction. There's no change in the blood volume because everything is closed. The pressure is going up, but volume stays the same. Once you have the opening of the aortic and the pulmonary valves, you'll see a very quick decrease in blood volume. That's because now this is the ejection. The blood is being pumped out of the ventricles until you reach the isovolumetric relaxation. You'll notice for this phase, there is no volume change. That's because all 4 valves are closed. You see second heart sound? So you've closed both the atrioventricular valves and the semilunar valves. But once we've now decreased our pressure all the way down so it's nice and relaxed, the right and left atrioventricular valves, so mitral valve and the tricuspid, can now open up. That means we have a rapid inflow of blood from the atria into the ventricles, which are now fully relaxed. The blood keeps passively flowing in until you reach your next P wave. The cardiac cycle starts again. You get the active push from the blood into the ventricle. You go back through the whole entire cycle. What we're noticing here, the last bit of this chart, EDV, end diastolic volume, ESV, end systolic volume. And the difference, end diastolic volume minus end systolic volume, is your stroke volume. Basically, the stroke volume is the amount of blood pumped out of the ventricle per beat. So from this point when the ventricle is full and in its isovolumetric contraction, so it's full just before it contracts, through contraction to the end, which now it is stopped contracting, and it's in isovolumetric relaxation. So just before it opens the valves and accepts more blood. This blood decrease is your stroke volume. How much blood was pumped out of the ventricle in one single beat. So your stroke volume.